Okay, class. So this is the meaning and balancing of chemical equations. This goes along with obviously the notes for the writing chemical equations notes. That's the assignment. So the chemical equation is a chemist's shorthand expression for describing a chemical change. As an example, consider what happens when iron rusts. So when iron rusts, there we go. We have Fe plus O2, and that gives us a compound, Fe2O3. Okay. In this expression, the symbols and the formulas of a reacting substance are called the reactants. You guys have seen this kind of thing before, hopefully, and are written on the left-hand side of the arrow. The products of the reaction are written on the right-hand side of the arrow. The arrow is read as gives, yields, or forms, and the plus sign is read as an and. And sometimes the plus appears between the formulas of two reactants. It can be read as reacts with, as in iron reacts with oxygen to form iron 3 oxide. The plus sign does not imply mathematical addition, that we just like, if it did, then my product would look like this. Yeah, that's not me writing, that's the board. Yep, okay, forget it. Let's move on. As it's written now, the equation indicates a qualitative way what the substances are consumed. That means 1 Fe and 1 O2, and the reaction is Fe2O3. And what the new substances are formed. In order to have a quantitative information about the reaction must be balanced so that it conforms to the law of conservation of mass. That is, that there must be the same number of atoms of each element on the right-hand side of the equation as there is on the left-hand side. So balancing the equation is accomplished by introducing what we call coefficients. That's a T, there you go, in front of each formula. In the above equation, it's observed that there are 2 atoms of oxygen on the left-hand side and 3 atoms of oxygen on the right-hand side. To balance, let's put a 3 in front of the O2 and a 2 in front of the Fe2O3. Count. You now have 6 oxygens on each side of the equation. Please note that we had to put the coefficient 2 in front of the whole formula of Fe2O3, and here's what it looks like. So here's the 2 that goes in front of the Fe2O3. 2 times 3 gives us 6 oxygens here. Okay, that's 6 for oxygens. And then 3 times 2 gives us 6 oxygens here. Okay, the equation is now balanced. Oh, notice that I do not, this is very important, I do not change the subscripts of the formulas that I have already. So if I have O2 and Fe2O3, I cannot change these small numbers because the small numbers must stay the way that they are. So we can only put numbers in front of the compounds and the elements. This equation is now balanced. Oh, hang on a second, but you must see that Fe is not balanced. So if we take a look, I have 2 times 2 is 4 Fe right here. But I only have 1 Fe on this side. So how do I get 4 on the left-hand side? If I put a coefficient 4 in front, then that changes the number of Fe's that I have, and that's what happens down here. So there it is. I put a 4 in front of the Fe, and now I have the Fe's balanced because 2 times 2 gives me 4 Fe's, and then 4 is already in front of this one. And 3 times 2 is 6 oxygens, and 2 times 3 is 6 oxygens. Okay. The equation is now balanced because an equal number of atoms and oxygen atoms are on both sides of the equation. The equation can be interpreted to mean that 4 atoms of oxygen react with 3 molecules of 4 atoms of iron react with 3 molecules of oxygen to yield 2 molecules of iron 3 oxide. Excellent. Let's keep going. Here's an example of a chemical equation, and it looks pretty complicated. Here I have aluminum hydroxide plus H2SO4 sulfuric acid. On the right-hand side, I have aluminum sulfate plus H2O. Now, I have some guidelines. These are pure guidelines, and I'll show you how to use them. Start with the most complicated molecule first. If I were to choose the most complicated molecule out of the 4 molecules that are here, I would probably choose this one here because I see more subscripts and I have parentheses and a polyatomic ion. So I would probably choose that one. Now this one has 2 aluminum. How do I get 2 aluminum on the left-hand side over here where I have aluminum in a compound? I would probably put a 2 in front there, so now that I have 2 aluminum. But that also gives me 2 times 3. That also gives me 6 hydroxide. Okay, so 2 aluminum, 6 hydroxide. Now notice on the right-hand side, I have a 3 outside the parentheses, which means that I have 3 SO4s. What are SO4s? SO4s are polyatomic ions. So we're going to keep the SO4 together and not break it up into 1 S and 4 oxygen because I see SO4 on both sides of the reaction. So I have 3 on the right-hand side because of that subscript right there. So I'm going to put a 3 on the left-hand side. I do not have 4 SOs. I have 1 SO4. Otherwise, if I had more than 1, I would see parentheses, just like I do on this side over here and over here on the left-hand side with hydroxide. Notice I have parentheses there too, which means I have more than 1 OH. Okay, now sometimes we can write HOH for water, and I do that sometimes to show that water actually is 1 hydrogen atom and an OH as the negative part. And because I have 6 OHs over here, I jump to the other side and put a 6 in front here to give me 6 OHs. Notice that I have 3 times 2 for hydrogens, so that gives me 6 hydrogens. Over here, I have 6 hydrogens and 6 OHs. Okay, so now I have 3 times 1 because if there's no parentheses, then it looks like that. 3 times 1 gives me 3 SO4s. And over here, I already have 3 SO4s because of the 3 there. So let's go back through and make sure that I have the same number for both. So I have 2 aluminums, and over here, 2 aluminums. I have 6 hydroxides. Over here, I have 6 hydroxides. I have 6 hydrogens, 6 hydrogens. I have 3 SO4s, and here I have 3 SO4s. So my balancing then is a 2 in front of the aluminum hydroxide, a 3 in front of the sulfuric acid, a 1 in front of the aluminum sulfate, and a 6 in front of the H2O. And that's it. That's how you balance equations. More on this for sheet 1.